Hello and welcome. In this video we're going to be creating Crossy Road inside Unreal Engine 5 from scratch. So you're going to want to make sure that you have Unreal Engine 5 installed. You can do that by going to the Epic Games launcher and going to this UE5 tab and just installing it here. So once you have it, let's launch it. I'm going to head over to Games tab and I'm going to start in the third person project, and I'll just call this my Crossy Road project and create it. So my project's loaded. I'm going to change the layout of my project by going to Windows and going to Load Layout and change it to UE4 Classic Layout, because I'm just used to working in Unreal Engine 4, but you can leave your layout if you want to. I'm just going to change mine. So the first thing you want to do is we're going to import some assets that we're going to use to make our Crossy Road game. So I'm going to right click on here and create a new folder. I'll just call this Crossy Road Assets, and I'll just double click and go inside here, and I'll leave a link in the description of these Crossy Road assets where you can download them so you can use them. So I'm just going to select them all and just drag them into my project, and you just want to click import all and then wait for them to load. So once it's imported, you should have a model of a truck, a rock, a chickens, a car and a big tree. So now that we've imported the assets for our Crossy Road project, we're going to replace this third person character with our chicken character. So to do that, if we head over to the third person BP folder, and I'll go to my third person character, and if we just go to the viewport tab and select the skeletal mesh, we can go over here and just clear it as we don't need this, and instead we're going to go to add and look for static mesh, and I'll just call this my chicken. And with this selected, if we go over to the static mesh tab, we can select the chicken model that we just imported, and I'm just going to rotate it so it's facing the correct direction, and we'll make the capsule fit around it. So I'll just select the capsule and adjust it, and now if I click compile and I click play, I should be my chicken character and I can move around with WASD. But in Crossy Road the character hops, so next we're going to change it so our character hops instead of moving with the normal WASD keys. So to set that up, if we head back to our third person character and go to the event graph, we can just delete everything in the movement input section. So if I just delete this and delete the nodes here, so when we press our forwards and right key, we're going to launch our character so that he hops. So I'm going to drag off the move forward and look for launch character. And we're going to be launching our character in the X, Y and Z axis. So if we just right click here and look for split structure, and then we just want to also just check these two boxes. This will make it so that we move by the values that we put in here. So when we press the forward key, we're going to make our character move up in the Z axis by 200, and we'll make our character move in the X axis. So to do that, we'll just drag up here and we'll look for multiply, and the value we'll select is going to be 240, and we'll just connect this into the X. So when we press the forward key, we'll move forward, but if we press the backwards key, our character will hop in the opposite direction, which is why we've just connected the axis value. Next, we want to make sure that our character only moves forwards if our character is pressing down on the forwards or backwards key. In order to do that, we can drag off the axis value and look for absolute, and then we're going to drag off here and look for greater than, and the value we'll put is 0.3. So if our character has his key on the forwards or backwards key, the value of this would be around 1. So we're just making sure that our character is pressing down on the keys if he wants to move forward. So I'll drag off here and then look for branch, and if this condition is true, then we'll launch our character. And we'll do the exact same for when we move right or left. So I'll just select everything here, press Ctrl C, and then press Ctrl V, and plug this in here, and this in here. But this time, instead of moving in the X axis, we'll move in the Y axis. So I'll just plug this in here, right click here, and break the link. And now I click compile. So if I click play, if I press the forward key, my character moves forwards. If I press the backwards key, my character moves backwards. And the same happens when he moves right or left. So now we've set it up so that our character hops. And another thing, if I click the play button and I repeatedly press the forward key or the right key, my character will just be continuously launched into the air. So next we're going to add some restrictions to our player's movement. So if we go back to our third person character, before we launch our character, we're going to check to see if our character should be able to jump. And we'll do that by creating a new variable. So if we go to the variables tab, and you just want to name this can move, and then compile, and by default you want to make sure that this is checked. So we'll only allow our character to jump if we've told the game that we can move. So I'm just going to move this back a bit, and off the boolean I'm going to drag off here and look for and boolean, and we'll drag in our can move variable and plug this in here, add this into here, and we'll do the exact same for our movement right. So I'll just copy this, so next we're going to set up a custom event. So every time my player moves, there's going to be a cooldown where they can't move, so that they can't repeatedly launch the character up in the air. So to do that, if we right click and look for add custom event, and we'll call this movement cooldown, and when we call this event, we'll just drag off here and look for do once, and then we'll drag in our can move variable and set it so that we can't move, and then we'll drag off here and look for delay, and we'll have a delay of 0.5 seconds before our character can move again, and we'll just copy this variable and paste it here, and then check it, and then plug this into the reset. I'm just going to double click here to make it a bit cleaner, and then if we successfully can move and are pressing down on the key, we'll then call this movement cooldown event. So I'll just drag it here and look for movement cooldown, and I'll add it here, and this will just prevent my player from spamming the key. So now if I click the compile button and I click play, I'll only be able to move every 0.5 seconds. So next we're going to set it up so that the player faces the direction that they're hopping in. Currently if I hop backwards or left or right, the player doesn't face to turn towards the direction that they're hopping in. So we'll set that up now. If I go back to my third person character, and I go to the input move forward, which controls if my character moves forwards or backwards, we can drag off the axis value. I check to see if it is greater than 0.3. I'll just drag off here and look for branch. If this value is greater than 0.3, that means my player is pressing the forwards key. I want the player to face the forwards direction. If this is false, that means my character is pressing the backwards key and we want them to face backwards. So first we'll set up what happens when my player presses the forward key. So we'll drag in our chicken. I'm just dragging off here and look for set world rotation. And off of the rotation, we're going to drag off here and look for lerp rotator. So what this will do is it will lerp our chicken character's rotation from A towards the value of what we put in B. So for A, we can just drag off here and look for get world rotation and plug this into A. And for B, we want it to be 90. This will just ensure that our character is facing forwards. And what this alpha will do is, when this value is 0, my character's rotation will be A, but when this value is 1, our character's rotation will be B. So that we can control the value of this alpha, we can create a timeline which will control this. So if I right click and look for add timeline, I can add this timeline, and I'll just plug this into play from start. And if I just double click and go inside this timeline, we want to add a flow track, and you want the length of this to be very short, so like something like 0.3 should be fine. And I'm just going to right click here and look for add key to curve float, and at a time of 0 you want the value to be 0, and then you want to add another key curve, so you just right click again and add key to curve. At a time of 0.3 you want the value to be 1, and then if you just click these little arrows it will zoom in, and if you just select the first one, right click and go to auto, this will just make it a bit smoother. And then if we go to the event graph, we can plug this into the alpha and plug update into set world rotation. So I'm just going to move this so it's a bit cleaner. And then we're going to do the exact same thing for the opposite. To save time, we can just copy everything, so I'll just select and press Ctrl C and then Ctrl V. and plug false into play from start. Although this time we'll move it to -90. And one more thing, you just want to check this little box which says shortest path. This will just make it take the shortest path. And then we'll do the exact same thing when we're turning left or right. So I'll just move this up a bit because I positioned this quite badly. So we'll just drag off the axis value and check if it is greater than 0.3. I'll drag a theme for a branch and plug this in here. If this is true, that means we're trying to face the right direction. So I can just copy all of this, press Ctrl C and Ctrl V, plug this into play from start. Although this time the value will be 0. And then I'll just copy this again, but this time the value will be -180. Okay, I just realized I put the wrong value for the one here. It should just be +90, and this one can be -90. And now if I click compile and close this and click play, if I hop to the right, my character turns. If I hop backwards, my character turns. So now my character is turning towards the direction that they're hopping in. With this, we've set up the movement for our character. So next we're going to create 3 different terrains that our character can hop on. A grass terrain, a road terrain which will have some cars, and a water terrain which will have some floating logs. So the first terrain we're going to set up is going to be a grass terrain. And on the grass terrain, we're going to make it randomly spawn trees and rocks in between the terrain. So to set that up, if we go to our blueprints folder, we're going to right click and look for blueprint class and look for actor, and I'll just call this my tree/rock. Okay, I'll just call this my tree rock spawner. And then if we head inside here and go into add and look for static mesh, and I'll just leave this as static mesh. If we select it and go to the static mesh and then look for big tree, and it's going to be a bit small because I already tested it. So you just click this little block icon and then type in 6. This will just make it a bit bigger. Next, we're going to make it so that when we place this into the world, it will randomly be this tree model or the rock static mesh model. To do that, we can go to the event graph and we can just delete these 2 nodes. And we want to right click and look for switch on integer. And then we want to right click and look for random integer in range. Then you just want to add 2 pins, 0 and 1. And then for here, you want the minimum value to be 0 and the maximum value to be 1. And then you just want to plug this in here and event begin play into here. So event begin play, we're going to make this be either the rock or the tree model. So in the event graph, if it happens to be 0, we're going to do nothing. However, if it selects 1, we're going to drag in our static mesh and then look for set static mesh, and we'll set it to be the rock model that we imported. And then we'll just plug this into here and compile. So next we're going to set up our grass terrain, and on our grass terrain we'll make it spawn this tree rock spawn blueprint that we just made. So I'm going to create that terrain. So I'll right click, look for blueprint class, select actor, and I'll call this my grass terrain. And then I will head inside here and go to add and look for static mesh. And this time you want it to be just the default cube. And for the dimensions of it, just make sure this is unchecked. And you want it to be 35 in the y-axis. I'll just zoom out, and 0.2 in the z-axis, and just 1 in the x. And then to make this look like a grass color, I'm just going to select this green material so it looks like it's on a grass terrain. And then on this grass terrain, so it knows where to spawn the tree/rock spawn actor that we made, you want to go to add and look for scene and just call this start. And you just want to move this here, and I'll just move it up a bit And then you just want to Control C and Control V and move this towards the end. And you just want to rename this. So rename this end. And you see how this green arrow is facing this direction? You just want to rotate it so it's facing the opposite direction. So by 180, so that it's facing this direction. And we're going to make our grass strip spawn between the start and this endpoint. So to do that, we can head back to the event graph. And we can just delete these two nodes. And event we can play, we're going to get our start, and we're going to get its world location. And then you just want to right click on this and promote this to our variable and call this our start location. And then we'll do the same with our end, so we'll drag it in, get the world location, and right click on this, promote it to a variable and call this our end location. And the event we can play, we're just going to connect this into here and this one into here. Next, you want to right click and look for distance. I'll just scroll up and I think it's this one, distance vector. And then we just want to drag in our start location and our end location. So plug this one into V1 and this one into V2. And then we're going to divide this value, so we'll divide the distance between our start and our end location by 85. Then we want to right click and look for loop, this one, and if we drag off here and look for trunicate, this will just convert this float number into an integer number, and then we can plug this in here and this here. So what we're doing is we're getting the distance between the start and the ending location, dividing it by 85, and that'll be a certain value, and that's the amount of trees or rocks that we're going to spawn across this strip. And then for each tree or rock, we want to spawn it. So if we just drag off here and look for spawn actor from class, we are going to spawn our tree rock actor that we made. However, we don't want to spawn a tree rock actor across every part of this strip, so we can prevent that by right clicking and looking for a branch. We're only going to spawn a tree rock actor if a certain condition is met, and that condition is going to be if we right click and look for random float. This will generate a float between 0 and 1, and if this value is greater than, let's say, 0.8, we will make it spawn our tree rock spawn actor. So next we need a location of where we're going to spawn our tree rock actor. So if we just right click on here and look for split structure, so where we're going to spawn it, we're going to drag off this index and look for multiply, and we want to multiply it by 90. So we're going to make sure that if a rock or tree spawns, that they're 90 units away from each other. If I head back to the viewport, we're going to be making sure that our tree / rock actor spawns across the y-axis. So if I head back to the event graph, I'm going to drag in my start location and drag off here and look for break vector. I'll just drag off here and look for add and plug the y in here. So we'll make sure that if a thing spawns that it's 90 units apart from each other in the y-axis. And then we want to drag off here and look for make vector, but we just want to plug this into the y. And for the x and z location, we can drag in our start location, right click, split structure, plug this into the x, and plug this into the z. And then we just want to plug this into our spawn transform location. And if I click compile, and go to the viewport and go to simulation, it will randomly spawn rocks or trees across our grass strip. So with that, we set up our grass terrain. Next, we're going to set up our road terrain, which will have random cars on it. So first, we're going to create our cars, which will spawn on our road. So if I just right click, look for blueprint class, actor, and I'll just call this my vehicle. Then if we just double click and go inside here, and we're going to go to add and look for static mesh. Whoops, I just selected the wrong one. So if you go to add and look for static mesh, I'll just call this my vehicle. And for my static mesh, I'll just make it the car. I know that this car's in the wrong direction, so I'm just going to go to add and look for arrow. And this arrow shows the correct facing direction that the object should be. So I'm just going to go to my vehicle and rotate it so it's facing the correct direction. And I'm also going to go to add and look for box collision. And just make this box collision fit around my car. Because later we're going to set it up so that if the player overlaps this box collision, that they will die. So once you've set that up, to make this car move, we're going to give it some projectile movement. So we just go to add and look for projectile movement. And there are a few settings we need to change. So we go to details, we want to look for gravity, and just change this to 0. This will just make it so it's not affected by 0. And then if we go to initial and max speed, we just want to put this at a value of 300. So this will be the initial speed of the car, and this will be the maximum speed that the car can go. And now if I just click simulate, this car should move forwards. So this is what we're going to be spawning on our road. However, I also have another vehicle called the truck. So we're going to make it randomly be this vehicle or this truck. So it'll be very similar to the system we set up for our tree rock spawner. So in fact, I think I can just copy this with Control-C and go to the vehicle and just paste it here. So I'll just delete this and plug in my vehicle and plug this in here. Although this time we'll make it I think it's called truck. Trucks are much slower than cars, so we want to reflect this. So if it does decide to make it a truck, we can drag in our projectile movement and drag off here and look for set initial speed and set max speed, and I'll just set it to be 250 and 250 here, so that if it is the truck, it moves much slower. And we can plug this in here and this in here and just click compile. So now we have set up our road. So we set up our vehicles. Next we're going to set up a road terrain for our cars to be spawned upon. So I'm just going to select this grass terrain, press Ctrl-C and then Ctrl-V, and I'll just rename this my road terrain. We can head inside here and go to the viewport, although this time I'm going to change its color so it looks like it reflects the road a bit more, so I'll make it this grey material. Then if I head back to the event graph, we can just delete everything here. We'll still need the start and end location, as we'll use this location to determine where we spawn our cars. So next you want to right click and look for spawn actor from class, and the actor we're going to spawn is going to be the vehicles that we made to go along our road. If we then just select the spawn transform and split the structure, we're going to be spawning our vehicles from our starting location, or, so you just want to select this and press Ctrl-C and Ctrl-V, or we'll be spawning our vehicles from our end location. So I'll just plug this in here. So if I just go to the viewport, we'll either start spawning our cars from the start and they'll go in this direction, or we'll spawn them from our end location and they'll go in the opposite direction. So to set this system up, I'm just going to move this a bit. We want to right click and look for set timer by event, and you just want to drag off this event and look for add custom event, and we'll call this spawn vehicles, and you just want to click this looping, and for the time you want to look for random float in range. So I'm going to make it every 2 to 3 seconds. So every 2 to 3 seconds it's going to do this event called spawn vehicles, and we're going to make this randomly decide to start spawning vehicles on either the starting location or the ending location. So to do that, we can just drag up here and look for branch, and I'll create a new variable. So I'll right click on this parameter variable and I'll call it starting car location. And if this variable is true, we'll start spawning cars from the start side. If it's false, we'll spawn it from the end side. In order to determine what this value will be, we can just drag this in here. And when we do the event begin play, we can just right click and look for random ball. And it will just randomly decide if it should be spawning from the start or the end location. So I'll just connect this up and connect this in here. And I'm only going to want to spawn vehicles some of the times. So I'm going to drag off here and do another branch. And I'm just going to copy this random ball. And if this condition is true, then I'll spawn a vehicle. If it's false, then I won't do anything. And now we've set up a vehicle for our road. Click simulate, it should start spawning my cars on either side of the road. Okay, so it looks like it's going in the wrong direction. Let me just check. So if I go back to the event graph. So for my vehicle, I've made the starting rotation wrong. So if I just make it 90 in this axis and 90 in the other axis, and just compile, close this, and then reopen it, go viewport and simulate. It starts to spawn my vehicle, and this time it decided to start spawning vehicles from this side, and they've all been trucks. This one was a car. It looks like they're a bit high, so I'm just going to move my starting and ending locations a bit lower. So I'll just select them both and move them down a bit. And if I just click compile and save, we have now set up our road terrain. So next we're going to set up our water terrain, and on this terrain, if our player reaches it, they're going to have to jump on logs. They're not going to be able to actually get on this terrain. So let's set up our logs. So our logs can be very similar to our cars. So I'm just going to select this, press Ctrl C and then Ctrl V, right click and rename this my log. If I head inside here, we can go to the viewport and we can delete this collision, we won't need it. So if I just select my static mesh and look for the log model that we imported earlier, and I'm just going to rotate this so it's facing the correct direction. And I found this log model to be a bit big when I initially made the game. So if you just select it and scale it down to 0.7, and for the projectile movement, because this can be a log, you want it to be a lot slower. So I found a speed of like 180 works. So I put 180 for initial and the maximum speed. And if we head back to the event graph, we can just delete everything here as we don't need it, and then just click compile. So now we're going to make our water terrain. So it's going to be very similar to the road terrain. So we can just select it, press Ctrl C and then Ctrl V, right click, rename this, and I'll rename this my water terrain. We can head inside here, go to the viewport. I'll just select this road and I'll change it to be our water material. Okay, I don't really have a water material, so let's create one. I'll just right click, oops, I'll just right click in some free space, look for material, I'll call this my water. We can head inside here, I'll right click, look for constant, and you want to select constant 3 vector, and plug this into the base color. Just select, double click inside here, and I'll make this like a blue color of some water. Just click OK, and just apply. And then we can just close this, head back to our water terrain, and from the material we can select this water one. And then if we head back to the event graph, instead of spawning vehicles, we're going to be spawning some logs. So I'll just look for my log that we just made, and we'll just look for this log again. And if we go back to the viewport, for this water terrain, we don't want the player to be able to touch it. So if you just select it and scroll down, by default it will be set to block all dynamic. This time you want to set it to overlap all, so that if my player jumps on this, he falls through. We want it so if the player jumps, he will jump onto the log. And now I just click compile, and I'll just click simulate to test it. Eventually a log appears. So I'll just stop the simulation, And with that, we set up the different terrains for our Crossy Road project. Next, we're going to create a terrain spawn system which will spawn one of our random terrains, grass, road, or water, in front of our player indefinitely until they die. So let's set the system up. We can just right click in our blueprints folder, select blueprint class. I'll select an actor and I'll just call this my terrain spawner. If we head inside here, we want to go to add and look for static mesh. And for the static mesh, you just want to select the cube. We're just doing this so we can see our terrain spawner in the world. So let's set up our system. If I head over to the event graph, I'm just going to delete these nodes as we don't need them. And then if I just drag off event begin play, you'll look for loop and just select this one. And for the last index, you're going to select 30. So what we're going to do is we're going to spawn 31 different terrains in front of our player. The reason it's 31 is because it counts this 0 index as a number. When we spawn our terrains, we're going to want them to be in front of each other in the x-axis. So in order to spawn our terrain in front of one another, we want to drag off our index, which will be which terrain number we're spawning, and then look for multiply, and the value we're going to put inside here is 100, and we're going to be spawning our terrain 100 units in front of each other in the x-axis. So in order to get that, we can drag in our static mesh and use it as a reference point. So I'll drag this in and drag off here and look for get world location. Then I'm just going to right click and look for split structure, and then we can drag off here and look for plus. So sorry, it's called add, and you want to plug the x-axis into here, and then you want to create a new variable, and we'll call this spawn location. So we're going to be spawning our terrains at the spawn location. We just need to change this to be a vector so it can store x, y, and z values. So I'll just drag this in and look for set spawn location. Right click on here and look for split structure. And you just want to plug the x in here and plug the y in here and plug this into here and plug loop body into here. So when we spawn our terrain, we're now going to be spawning them 100 units in front of each other. For the first couple of terrains that we spawn, I want them to all be grass terrain so that the player doesn't start spawning on a road or a water terrain. So in order to get that, I can just drag off this index and look for in range integer and select. So the first 4 terrains I'm going to spawn, I'm going to make them grass. So I'm going to make the minimum value 0 and the max value 0. Sorry, and the max value 3. And I'll just drag off here and look for a branch. And for the first 4 terrains that I spawn, I'm going to make them grass. So I'll just drag off here and look for spawn actor from class, and I'll select the grass terrain. And I'll just right click on spawn transform, split the structure, and just drag in my spawn location. I'm actually going to change this max value to be 2, so the first 3 terrains I spawn are going to be grass terrain. After I spawn these first 3 grass terrains, I'm going to drag up here and look for a branch, and I'm going to make the next 3 to 9 terrains I spawn random terrains. So I'll just drag up here and look for the in range integer node that I just made, and then for the minimum value we're going to make it 3, and for the maximum value we'll make it 9, and we'll just plug this into here. And if it's between the 3 and 9 value, we'll make it spawn a random terrain type. So to achieve that, we can right click and look for switch on int, and we're just going to add 4 different nodes, and I'm just going to right click and look for random int integer in range, and we'll make it go from 0 to 3, and I will just connect this and plug true into here, and we can just select this with Ctrl Z, and you want to paste it 4 times. So 1, 2, 3, 4. So if it goes on 0, we'll make it spawn a grass terrain. If it goes on 1, we'll make it spawn a grass terrain. So it's more likely to spawn a grass terrain. If it goes on 2, we'll make it spawn a road terrain. And if it goes on 3, we'll make it spawn a water terrain. Now I want this terrain spawner to go on forever and ever. In order to achieve that effect, on terrain number 10, we're going to make it spawn this collision, and when we overlap this collision, it will spawn another set of terrain. So I'll just drag up here and look for equal, and if this is equal to 10, so on our 10th piece of terrain that we spawn, we'll spawn some collision, which if we overlap will spawn some more terrain. So I'll create a branch and plug from the false into here. For my 10th terrain, I'm also going to make it be a grass one, so I'll just select this with Control C and then press Control V. And then also on this grass terrain, we'll make it spawn some collision, which if we overlap will spawn some more terrain. So I'll just drag up here and look for spawn actor from class. So we need to just quickly make this collision actor, which if we overlap will spawn more collision. So I'll just right click here, look for blueprint class, select actor and just call this more collision. Then if I double click and head inside here and go to add and look for box collision, you just want to make sure if we scroll down we go to overlap all, and then when I scroll up you want to make sure this is unchecked, and you just want to make this 59 in the y-axis and around 1.2 in the z-axis. Then you click compile and go back to our terrain spawner. For the class we're going to be spawning our more collision, and we're going to be spawning this on top of our 10th terrain. So I'll just plug this in here, right click, split the structure and plug spawn location into here. And then to make it so that when we overlap this it spawns more terrain, you're going to drag off here and look for event begin overlap and click to bind event to on actor begin overlap. Whoops, select the wrong one. You're going to drag on here and look for actor begin overlap. So assign on actor begin overlap, you want this one, and you want to plug this into here. So when we do this, it will call this event, and on this event we want to check to see that our third person character is overlapping this. So we'll drag off other actor and look for cast to third person character, and if our third person actor is overlapping this, I'm going to drag off here and look for do once, and we are going to spawn actor from class, and we're going to spawn another terrain spawner, and while we're going to spawn it you want to right click here and look for split structure. And if I just zoom out, so earlier we made it so that we're going to spawn 31 random terrains at once, and we start off spawning our terrains by using our static mesh location. So when we overlap this collision, we're going to spawn another terrain spawner, which is this actor that we're working on, 31 units in front of our original static mesh location. So to get that location, you just want to drag in the static mesh and drag up here and look for get world location, right click and look for split structure, and then we're going to drag in our spawn location, set spawn location, right click on here and split the structure. And then we just want to drag up here and look for add, and you want to add 3100 because we're spawning units 100 units in front of each other. So we're going to be spawning another terrain spawner, this actor, at the 31st location. So we're going to spawn it at 3100 units in the x-axis ahead of it. So you just want to plug this into the x-axis, and then you want to plug y into y and z into z, and then you'll plug completed in here, and this into here, and this in here, and then click compile. So at our 10th one we'll spawn this grass terrain. On this grass terrain we'll spawn this small collision, and if we overlap this small collision it will spawn another terrain spawner 31 units in front of our original location. So after we do this, so I'm just going to drag up here again and look for in range integer the remaining ones, so number 10 to number 30 I'll drag off here and look for branch. Park this in here. The remaining 20, we will just randomly choose them, so I'll just plug this back in here and click compile. Then we also want to go to the viewport, and in the details panel you want to look for hidden in game, so let's just make this hidden in game. And we also want to scroll down and make its collision no collision in case the character spawns on top of it. And then just so we can see this more collision, just so you can see it, if you go back to it and in the details look for visibility, you want to look for hidden in game and just uncheck it. Let's just make it so we can see this in the game. And I'll just click compile. I'll close this. I'm just going to delete all these actors quickly. I'll just drag in my terrain spawner. I'll just drag it on top of my chicken. Sorry, I'll just drag it a bit below my chicken. I don't want it on top of it. So now if I just click play, it'll spawn my random terrain. Okay, it looks like I put the scenes a bit high, so I need to lower them. So I can just hop forward. So as you can see, on the 10th one, you can see that collision. So let's just get to it. So I'll just wait for a log to. Okay, so a log appeared. So on the 10th one, if I overlap it, it should spawn some more terrain in front of me. So if I overlapped it, as you can see, it spawned a lot of terrain in front of me. So I can see there are a few problems. So next we're just going to fix those out. So I'm just going to make a few minor changes. I'm going to head back to my grass terrain, and it looks like, yeah, the rock and the tree spawned a bit above the ground. I'm just going to move them a bit down so they spawn hopefully on the ground. And I'll just see how the vehicles were doing. So it looks like the vehicles are spawning at a good distance, so I'll just leave them. I'll move my grass and rock trees a bit down, so I'll just select them. And if we just go here, we can set the snap size to 1 so we can be really specific. I'll just move it a bit down to 4, and that should hopefully be fine. Another thing, if you get the play button and you go next to, say, a rock, you can see it just completely messes with the camera view. In order to prevent that, if we go to our rock / tree actor, the viewport, and select the static mesh, you want to scroll down, and under the collision presets, you want to change it to custom, and you want to set it to ignore camera so it doesn't mess with our camera. We'll do the exact same thing for our logs and our cars and our vehicles. So I'll just select this, scroll down, custom, and ignore camera. And I'll do it for the vehicle, so I'll select the vehicle, scroll down, custom, and ignore camera. Then I'll hit compile, and I'll close this and hit play. If I go next to the tree, it doesn't mess with the camera at all. And there's one other fix we need to do. If I click the play button, my character can jump to the left even if there's an obstacle to the left of them, or they can jump in front even if there's an obstacle in front of them. So we're going to set up a system which will prevent the character from jumping to the left or right if there's an obstacle in front of them. So if we go back to the third person character, the way we're going to do this is by using a box trace system. So every time my player presses the forward or right key, we're going to do a box trace. And if this hits anything, that will mean there's an obstacle in front of them and we won't allow them to jump. So in order to do that, we can just drag off after we press the jump button, drag off this branch and look for box trace by channel. And I'm just going to right click here and break the link. And just do this in an area with a bit of space. So where we're going to start this box trace, you want to right click and look for get actor location and just plug this into the start. And for the end location, what we want to do is just drag up here and look for plus, so vector plus vector, and what we'll be plussing, we will right click and look for get actor rotation. From here we want to drag up here and look for get forward vector, and we want to multiply this by a number, and the number we'll be multiplying it by is, if we right click again and look for multiply, and you just want to plug this axis value in here to the top, and here you want to put a value of 100 and connect this to here and this to here and this into the end. So we're going to be checking either 100 units in front of the player or 100 units behind the player. That's what this axis value will allow us to determine. And the size of this box trace, and the half size, you just want to put 100 everywhere. And I'm just going to put the draw debug type for full duration so you can see the box trace. And then off the return value, you just want to drag up here and look for a branch. So if this hits something, then this will be true, and we don't want to move. So if this is false, then we'll just plug this back into our normal system. And we're going to use this exact same system for if our player is moving to the right or to the left, if we're checking if an object's in front of them. So I'm just going to copy all of this with Control C and then Control V and plug true into here and plug this into here. Although this time we're not going to be using the forward vector, we're going to be using the right vector. So if we just drag up here and look for get right vector, and you'll plug this in here. And this time we'll be using the input axis from the move right key. So I'll plug this into here. And now if I click compile, one more step. For the return value, I just need to drag up here and look for a branch and connect this. And if this is false, which means we didn't hit anything, we'll allow the player to move. So I just click compile, close this and play. Okay, it looks like I made the box collision a bit too big. So I'm going to go back to my third person character and change the size of it. So I'll make it 10 in each axis. And now I can compile and play. I can move. So if I try to move to the left, I can't because there is a rock to me, and I can move to the right, but if I try to move to the right again, it won't let me because there's a rock in front of me. So using this, we have made it so we can't just bump into obstacles. So if you just want to remove the red line traces, just go back here, and for the forward duration, just make it none, and make it none, and then click compile. So next we're going to set up a score system and a game over system. So the player will be able to die, and the player will also have a score for how far they made it in the game. So we'll first start by creating the score system. So we go to the third person character. We're going to go to the variables tab and just click add variable, and we'll just call this our score. So for the variable type, you want to make sure that this is a float, so it could be a number. So I'll just compile this, and you can see we'll store this score as a number value. So every time my player steps on a terrain, like the grass terrain, or the road or the water terrain, we'll update their score. So to update their score, we'll do this with a custom event. So if we right click and look for add custom event, and I'll just call this event update score. So to update, when we update our player score, we'll just drag in their score variable, get it, and we'll drag up here and look for increment. This will just increase it by 1, and then we'll drag in the score value and look for set score, and just plug this in here and this into here, and then click compile. To register this event every time we step on a terrain, we can first go over to our grass terrain and into the event graph, and if we just select the static mesh and right click and go to event hit and look for add on component hit. If the other actor is the third person character, which is what our character is called, we'll drag up here and look for cast to third person character. We will then drag up here and look for do once, and then as a third person character we will update their score, so we look for update score, and we can just plug this in here and click compile, and I'll just select this with Control C, and then we'll post this into our road terrain. And then if I just go to my water terrain, this one's going to be a bit different because our player is not going to step on this terrain. So I'm just going to do add and look for box collision, make sure overlap all, and I'm just going to scroll up and just increase the scale of this to be like 52, so it's wide, and I'll just move this a bit above, and I can just scroll down, go on component, I don't see it, but it's on component begin overlap. We can cast to the third person character, do once, and update their score, update score, and just plug this in here and go compile. So that we can visually see the player's score, we can, I'll create a new folder for it. So I'll right click, create a new folder, and just call this UI. Go inside here, right click, and look for user interface, widget blueprint, and I'll just call this my player HUD. If we go inside here, in the palette, you want to look for some text, and I'll just make this text a score colon, and then next to this will display our player's score. So I'll just drag in some text, and this text will display my player's score. So in order to make it do that, we want to click on this bind, create binding, and we can just drag up here and look for cast to third person character. As a third person character, we can get their score and just display it. This needs an object reference, otherwise it won't compile. And in order to get that, you can use the player controller. So you look for character. So you look for get player character and just plug this in and then click compile. So that we can actually see this HUD when we start the game. If we just close this, head back to our third person BP folder and go to our third person character. We can right click and look for event, begin play, and when we can play, we can create a widget, and this widget is going to be play hard, and then we can add this to the viewport and compile and close this and click play. And as you can see, it shows my score in the top left. If I move forward, my score will increase and continue to increase. So I'll just wait for this log. Okay, I'll just run for this log. Okay, it looks like my box collision system is messing with the logs. So I'm going to head to my water train, and I'm going to make my starting and ending locations of my log spawn a bit lower to the ground so that my box collision doesn't mess with it. So I'm just going to temporarily turn them back on so I can see if it still hits them. Okay, so that seems to be low enough. So just make sure that when you set up the box tray system that you move the logs a bit lower, because you don't want this box tray system to hit the logs, otherwise the player won't be able to jump on the logs in the water drain. Okay, so with that we have set up our score system. We're now going to set up so that the player can die by either being hit by a car or if he jumps into the water. So first let's set up what happens when my player gets hit by a car. So I'll just go back to my third person character, right click, create a custom event, and I'll call it hit by car. If my player is hit by a car, then we're going to drag in the chicken and look for set world scale 3D, plug this in here. If I just select my chicken, we can see it is 1 in all axes, all the axes. When my player gets hit by a car, we're just going to make it go 0.1 in the Z axis, so it looks like it's been squishing. So I'll just change it back to 1, head back to my event graph. So for the Z it was 1, sorry, for the X it was 1, and for Y it's 1, and for the Z we'll make it 0.1. And then when we get game over, we're going to show a game over screen. So I'll just close this, go to my UI, create another one, go to my user interface, widget blueprint, call this game over, create this UI, I'll look for some text, place it in the middle, and go to my anchor, just select it in the middle. This will make it so it stays like this on the screen. I'll make this text say game over, and I'll make it a bit bigger so I can change the size of it to like 50. Oops, I'll make it 100 because it's a bit small. and then I'm going to make it show this retry button, and when we click this retry button, we'll be able to try and play the game again. So if I just look in the palette and look for a button, I can just drag this into the screen. I'll just make sure I anchor this towards like the bottom of the screen, and I'm going to put some text in my button. I'll just drag some text into my button, and I'll make it say the words retry, and I'll make the font a bit bigger, and I'll just select my button, scroll down and go to on click. So when I click this button, it will open a level. So drag off here and look for open level by name, and the level we're going to open, we'll just drag off here and look for get current level name. So just get the current level that we're in, and we'll just open that level. So I'll just click compile, and when I'm my third person character, if I get hit by the car, I'm then going to create a widget, and this is going to be the game over, and then we'll add this to the viewport. When we show this game over screen, we're also going to need to show our player's mouse cursor so that they can click on this button. By default, I think it hides the mouse cursor, so in order to show it when we die, we're going to right click and look for get player controller, and from here we can drag up here and look for set show mouse cursor and just check it, and then this will show our mouse cursor once we die. And then if we're hit by a car, we want to make it so that the player can't move anymore. We can do that by dragging in character movement and looking for set max walk speed. So I'll look for set max walk speed, and we'll set max walk speed to be 0 so the player can't move once they've been hit by a car. So next we need to head back to our vehicles and make it so that if our player is hit by one, it calls the hit car event and my player gets game over. So if we just select this box collision we made a while ago and go to the events, you want to scroll down to get through these events, click the second one on component we can overlap, and on component we can overlap the other actor we will cast to the third person character, and then we'll drag up here and look for do once, and then we will call the hit by car event and plug this in here. And there's one more thing, if you just select the vehicle, you want to scroll down and just make this overlap horn. This will also just make it so this vehicle passes through the third person character as they use a pawn collision. So I'll just compile this and click play. If I just move forward and I go onto a road, if this truck hits me, I should get game over now. So this truck hits me, I go flattened, and now I get game over. Next we need to set it up so that if my player jumps into some water, they also get game over. So I'm going to go to my water terrain, and we made this box collision to count our player's score if he overlaps it. What you want to do is just press Ctrl C and then Ctrl V and move this box collision underneath, and we'll also just make this a bit smaller in the Z axis, so I'll just make it like 0.5 so it's a bit less wide, and I'll just move this a bit below the water. So when my player overlaps this, he's also going to get game over. So we go back to our third person character, I'm going to right click and create another custom event and call it fall in water. And when the player falls in water, we'll show the game over screen and then show the mouse and make it so they can't move. Then I go back to my water terrain and do the box one. Let's scroll down, go to on component, can overlap. I can cast to the third person character, do once, and then I can call the drown fall in water event, which I just made. Plug this in here, compile. Okay, that didn't compile because in the third person character I just need to compile it here. Then if I go back here and click compile, it should be fine. And now if I click play, if I fall into water, I just get game over. So I get game over and I fall through the map because there's no collision and I'll get game over. And then when I click retry, I get to try the game again. I'm just going to go back to my wall collision and set it to hidden in game so I can't see it anymore. And to my box tray systems and set them to hidden again. And then I just can compile, close this and click play. We have set up a Crossy road project in Unreal Engine 4. So that is all for this video. I hope you enjoyed. If you did, like, subscribe, and if you have any video ideas, just let me know in the comments below, and I will see you next time. Bye.